Hi there, and welcome to this lesson on mixed index radicals, which essentially means that we will be doing operations where radicals have different indices. So I'd like you to start with a little warm-up problem and see what you would do to simplify this expression that has two radicals in it and they have different indices. So pause the video, give it a shot, and then when you're ready, just resume. So what you'll see here is that if we convert these to rational exponents, which is why all that work in the previous lesson was done with rational exponents, we have x to the 1/2 times x to the 1/3. And we know that when we multiply, we add exponents. So we have to add the 1/2 to the 1/3. So that's basically x to the 3/6 times x to the 2/6, giving us x to the 5/6. Now, since the problem started out with radicals, we're going to finish the problem with radicals, and we're going to write this as the 6th root of x to the 5th. And there you have it. So we're just going to go through some more examples. We're basically going to convert each of these so that they are a simpler expression where there's only one radical in it, right? And so we're being told to express as a radical, so we will not leave our results with rational exponents. We're going to convert them to radicals, but there's only going to be one radical. So starting here, we have x to the 1/5 times x to the 2/3. We need a common denominator, so that's 15, so that's going to be 3/15 plus 10/15, giving us 13/15. So we basically have x to the 13/15. So that is the 15th root of x to the 13th. All right, so we've got roots over roots inside a root. So a to the 1/3 over a to the 1/4, and all of that is raised to the 1/5. So this is a to the 1/15 over a to the 1/20, because again, when we're raising to a power, we multiply exponents. So now we need a common denominator, and that's going to be 60. So I basically have 4/60 minus 3/60. And I'm doing subtraction because I'm dividing these two. So that's 1/60. So we get a to the 1/60th, which is the 60th root of a. And the last example here, x to the 1/3 times y to the 3/4 over z to the 1/2, and all of that is being raised to the 1/2. So x to the 1/6, y to the 3/8 over z to the 1/4. And so if I get a common denominator of, what's that going to be, 24? So we essentially have x to the 4/24, y to the 9/24, z to the 6/24. So that is the 24th root of x to the 4th, y to the 9th, over z to the 6th. And there you have it, a single radical. So there you go. Next thing we're going to do is just some more practice with some rational exponent stuff. So what I would suggest doing is just kind of going through and doing all of these, and then, so pause the video, do them all, and then check back for the answers. All right, here we go. So that's 1 over the 5th root of 32 squared, which is 1/4. This is the cube root of negative 125 to the fourth. So that's negative 5 to the fourth, which is 625. This is undefined because, that down, this is actually the square root of negative 25 raised to the third. And you can't take the square root of negative 25. Okay, so we flip this. So this is 27 over 8 to the positive 2/3, which means it's the cube root of 27 over 8 squared. And that is 3/2 squared, which is 9/4. Here we just need a common denominator, and that common denominator is 12. So it's x to the 8/12 times x to the 6/12 times x to the negative 3/12. So when we combine all those, 8 plus 6 is 14 minus 3, that's 11. So that's x to the 11/12. And then x to the 1/4, y to the 1/4, x. And what I'm going to do is I'm going to put everything in fourths, just so we have a common denominator for everything. So this is going to be x to the 6/4. So even though a lot of these fractions simplify, I just recognized early on that we were going to have a 4 in the denominator of all the exponents, and that's negative 3/4. So I have x to the 1/4 times x to the 4/4 is x to the 5/4 up top with an x to the 6/4 in the bottom. So that's going to leave us an x to the 1/4 in the bottom. I've got y to the 1/4, y to the 4/4, that's y to the 5/4, and the negative 3/4 will come up, giving us a total of y to the 8/4, which we can just write as y squared. There you go. Now a couple factoring examples. We will take out a 3. We got a factor of x, and it looks like 1/2 is the smallest exponent, and then y to the 2/3, leaving us with y to the 3/3, which is just 1, minus 2, and then x to the 2/2, which is an exponent of 1. So that is finished. And then here we've got a factor of x minus 1, and again taking the least exponent. And then we've got x plus x minus 1. And that's going to be squared. Right? 3/2 minus a negative 1/2 is 4/2, which is 2. So here we end up with x plus x squared minus 2x plus 1. So we get x minus 1 to the negative 1/2 times x squared minus x plus 1. And depending on whether or not you were instructed to leave answers without negative exponents, we could move the x to the minus negative 1/2, x minus 1 to the negative 1/2 down into the denominator if we so choose. So we'll either go with this, or you could say x squared minus x plus 1 over x minus 1 to the 1/2. All right, so there are all the solutions to these, and thanks for watching.